Today we will discuss about one problem which has appeared in Physics CSIR-NET and in 2016. So the question is like that. So the charge per unit length of a circular wire of radius a in the xy plane with center at origin is lambda 0 cos theta, where lambda 0 is a constant and theta is measured from the positive x-axis. Then we have to find out the electric field at the center of the circle. So let me explain these questions. So here it is a circular ring which has radius a, and the charge density, the linear charge density of this circular ring is lambda 0 cos theta, and theta is the angle measured from the positive x-axis, and this is the x-axis and this one is the y-axis. So now we have to find out, so what will be the electric field at the center of this ring. So now let's take a very small elemental length here which makes an angle theta, and if you take, so this angle is d theta and the elemental length is dl. Now let's find out the electric field due to this small elemental length, and then you have to integrate over all the rings, then you can find out the electric field at the center due to this whole ring. So now we can calculate the electric field due to the very small element, which is dE 1 by 4 pi epsilon 0, so dq by r square. R square means here the radius, which is a square. But what is the amount, what is the value of the dq? So dq is the dl times lambda 0 cos theta, because lambda 0 is the linear charge density and dl is the length, so charge in this small elemental length is dl times lambda 0 cos theta. Okay, here, so now our equation became 1 by 4 pi epsilon 0 d, this one is dl lambda 0 cos theta. But we know that this dl, we can write this dl in terms of a, that is the radius of these circular rings. So dl we can write as a times d theta. So now this expression for this dE becomes 1 by 4 pi epsilon 0 a times cos theta into lambda 0 into d theta. Okay, so we can write a by lambda 0 divided by s square. So one a will be cancelled out, so this became lambda 0 1 by 4 pi epsilon 0 times a cos theta into d theta. So this is the electric field due to the small elemental length at the centers. So if you want to find out the electric field due to whole circular ring at the center, then we have to integrate it over all along the length or the perimeter of the circle. But here is the problem is that the electric field is a vector quantity, so if you integrate these equations we will not get the exact value of the electric field, because electric field is a vector quantity, so we cannot add it as a scalar quantity. So then for that we have to find out the x component of electric field and x component of the y component of the electric field. So and we know that the x component of electric field and y component of electric field each are scalar, so then we can integrate x component and also we can integrate the y component, we can find out the whole electric field. So what will be the x component? For that x component, then let's put a unit test charge at the centers, because we want to calculate the electric field at the center. So electric field is nothing but the force experienced by a unit positive charge placed at the center. So that's why I placed a unit positive charge at the centers. So due to this elemental length, the electric field experienced by the unit positive charge will along this line. Now this is the direction of the electric field. So if I want to calculate the x component of electric field, that means we have to find out what is the angle of this electric field with the x axis. So this is the angle of the electric field with the x axis. That means this angle is theta, this angle is pi, so this total angle will be pi plus theta. So now my electric field, x component of electric field will be the dE cos pi plus theta, which is nothing but lambda 0 4 pi epsilon 0 times a cos theta and cos pi plus theta into d theta. And we know that cos pi plus theta is minus cos theta, so we can write this cos pi plus theta as minus cos theta, and cos theta is, so it's become cos square theta. Now if I want to calculate the whole total x component of the electric field, then it will be the integration over dx del Ex, which is integration over 0 to 2 pi. The theta will be start from 0 to 2 pi, so it will be 0 to 2 pi lambda 0 by 4 pi epsilon 0 times a cos square theta to d theta. Now our total x component of the electric field became lambda 0 4 pi epsilon times a integration over 0 to 2 pi cos square theta into d theta, and if you do this integration, this something like that 4 pi epsilon 0 a, we can write this cos square theta as 1 plus cos 2 theta divided by 2 to d theta okay. The first part will be there will be half common, so first part will be integration over theta 0 to 2 pi plus, and this part will be sine 2 theta divided by 2 0 to 2 pi, and this part will be 0 because sine 0 is 0, sine 2 pi is also 0, so this part will be cancelled out, so only remain minus lambda 0 4 pi epsilon 0 times a, and this will be half into 2 pi, so 2 will be cancelled out, pi will be cancelled out, this will be minus lambda 0 4 epsilon 0 times a, and this is along I cap, so this is the x component, so I can write it as I cap. So now look at the y component of this electric field. If you look at the y component, so y component of the electric field is the dE sine pi plus theta, which is minus sine theta times dE, and we know that dE lambda 0 4 pi epsilon times a epsilon 0 times a, and this dE cos theta into sine theta into d theta. So if you want to calculate the dE, which is the integration of d of the y component of the electric field, so minus lambda 0 4 pi epsilon 0 times a integration over 0 to 2 pi cos theta and sine theta and d theta, and we can do this integration. If I divide 2 and multiply a 2, so it became sine 2 theta into d theta, and this part is actually integration cos 2 theta 0 to 2 pi, and in this case it became 1 minus 1, so it became 0. So that means the y component is 0, so only the component remains, that is the x component. So the net electric field will be the along x component, and that magnitude will be minus lambda 0 4 pi epsilon 0 times a I cap, and which is the first option. So our answer is matching with the first option, so correct option is the first one. So this is the analytical method. So if you want to do this problem in a very simpler way, so you can do also by doing but not doing this all this analytical form. So just you can see that this lambda is varies with theta. So if I take theta is equal to 0, that means along these lines this will be plus lambda 0, and at this point this will be theta will be pi by 2, so pi by 2 means 0, this is 0 charge. So and here this will be minus, because cos theta cos pi is -1, so it is minus lambda 0, and this is 0. That means only the electric line charge will be here, charge will be minus lambda 0, and here charge will be plus charge plus lambda 0. If I put a positive charge here, it will move along this line, because this lambda minus lambda 0 will attract this positive charge and it will repel, so it will move along the negative x direction. So here you can see that there is only one option, in one option there is a negative x direction, so you can assume that this option will be the correct option. But not doing this long mathematics, you can just imagine, guess that this option will be the correct option.